welcome to a video on test-first programming. This is a very popular way to program these days, and I wanted to introduce it to you so that you could try it out when you're doing your assignments and other exercises. The idea behind test-first programming is that you test your code before you write it, and that might seem odd. How can you test something that you haven't created yet? And the answer is that you can't. You have to actually create it before you can test it, but that doesn't mean you can't write the tests first and just not run them until you've created the code. Why would you want to do that? Why would you want to write the tests before you write the thing that you want to test? And the answer is that when you're writing these tests and thinking about what tests you have to write, it forces you to think about the problem before you actually try to solve it. And the more you think about the problem and the things that can go wrong with the problem before you start coding, the quicker and more effective you'll be when you actually code. So I'm going to do this example in 3 programming languages: Python, Java, and C++. The concept is the same in all 3 of these languages. And let's get started first with Python. So here's the deal. Imagine you've been given an assignment in class or at your job to write a function called divisible that takes 3 parameters. The first parameter, and it returns a value, an integer. The parameters are integers. And if the first integer is evenly divisible by the next 2, your function should return a 1. If the first number is not evenly divisible by both of the next 2 numbers, it should return a 0. And it should return a -1 if there's some error condition that could happen. Okay, now that we understand what this function is supposed to do, we can now take some time to write some tests to make sure it works. And this is the process that's so important because it forces you to think about what the function is supposed to do and test to make sure it does it, and think about ways maybe we could find out if the function is broken. So what we do is we create a test suite, which is just a bunch of tests that we hope will pass when we're finished writing it. The first test, we're going to test to see if this thing actually works in the positive case, meaning that when the first number is evenly divisible by the other 2, it should return a 1. So we write a little code that calls the function with an 8, and you can see 8 is evenly divisible by 4 and 2. So we expect this to return 1. So we create an if statement to see if that's the case. And if it is, we print that it passed the first test. Our function is working so far. Now I'm going to try the case where it's not going to return 1. It's going to return 0 because 8 is not evenly divisible by the third parameter. It is evenly divisible by 4, but not by 3. So this should return a 0 because 8's not evenly divisible by 3. So I test that and print that it passed test 2 if that works. Okay, another place where we could get a 0 back is if the second parameter, if the first parameter is not evenly divisible by the second parameter. And that's what I'm testing here in test 3. So I figured out, well, here's another case where I should get a 0, so let's test for it. 16 is not evenly divisible by 7, although it is evenly divisible by 4. But in the situation where that's not true, for one of them, it should return 0. So I test that, and I print the error message. I print the fact that it passed the test. Okay, what could possibly go wrong? Well, if you remember, you can't really divide by 0, so it doesn't make sense to determine whether something is evenly divisible by 0, because you can't divide by 0. So if the second parameter is a 0, then that's an error. And I would expect my function to return a -1 there. So I'm going to call divisible, making one of these 2 a 0, the first one. And if it's -1, I print that it passed. And of course, something can go wrong here if the third parameter is a 0 as well. So we should test to see if that situation also returns a -1. Okay, that's a pretty good collection of tests that if these all pass, I can feel fairly confident that my function works. But of course, I can't run this until I've written the function. But I've learned about all the different cases that I have to think about, what I should return in those cases, and that makes me better informed to write that function, and then I can immediately test it to see if it works. Okay, so now I've gone off and taken a few minutes to come in here and write the function, and here it is. And I feel pretty confident it works. I'm feeling pretty good. I used all the information I learned when I wrote these tests, And now I can actually run the test to see if my program worked. Did I write it correctly? So we'll come over here and I'm going to run the program from my command line using the Python command. This is called main.py. I run the program and look, I passed test 1, 3, 4, and 5, but some reason I didn't pass test 2. Darn, I made a mistake when I wrote my function. Let's see which test didn't pass. It looks like the one where the third parameter here, the first parameter is not evenly divisible by the third parameter. So let's take a look and see where I test for that. Well, here's the case where I test for one of the two being equal to 0, and that's the error condition, because we can't divide by 0. And here's where I check for divisibility of the two other parameters. This is testing to see if the first integer is evenly divisible by the second, and that looks pretty correct to me. I do the mod. If the remainder is 0, then they are evenly divisible. And I'm also testing to make sure that the second number is evenly divisible by, oh, wait a minute, that doesn't make sense. I should be testing to see if the first number is evenly divisible by the third. These are the two things that have to be true for this to work. Okay, so because I found out what test I failed, it gave me a hint about what I might be doing wrong. And sure enough, there's the problem. Now let's run our tests again, and look at that. We've passed all 5 of our tests, and we know our function is in good shape and ready to roll. All right, let's take a look at the other languages just to see how similar they are. Here's the situation in Java. Notice how code is very similar. I have to create a class in Java for this to work, but I still write my tests and they still look very similar to what I had done in Python. And here's my function, and I've written my function, and sure enough, I made the same mistake. So if I run this, compile it first, and then run it from the command line, I should see whether or not my tests pass. And once again, they don't, and for the same reason. This should really be I1 mod I3. So I make the change, recompile it, and then we'll run it again, and this time it passes all 5 in Java. All right, finally in C++, again, looks very similar. We have our function header, which we don't have to do in Java or in Python up ahead, the function prototype. Here's our main function. Here's our test suite. Again, look how similar the code is in all 3 of these languages. And in this case, here is my function, which I have then written and made the same mistake. So let's compile this. Oops. Let's compile this in using G++ on the command line. And this is main.cpp. And then we'll run it. And sure enough, the same error condition as before. I failed test number 2. And we'll make the same fix. And we will compile and run it again. And sure enough, it passes the test. So now that you've seen this, I strongly recommend in your next assignment that you're given or exercises, try and write some tests to test the function you're trying to create or the class that you're trying to create or whatever it is you're being asked to do. Write some tests first. You won't be able to run those tests yet, but you can certainly write them. And try and write as many tests as you can and be as thorough as you can. Then write the function or class or whatever it is you're trying to build and run them against the tests. This allows you to find out whether or not you've done it right, and you should find that you're writing your code more quickly and with fewer errors by thinking about your tests first. Cheers.